The partition of a solute between two immiscible phases is an equilibrium process that is governed by the distribution law. If the solute species A is allowed to distribute itself between water and an organic phase, the resulting equilibrium may be written as A aqueous and A organic. The ratio of activities for A in the two phases will be constant and independent of the total quantity of A, so that at any given temperature, the formula will be K equals to over aqueous. Note that the equilibrium constant K is known as the distribution constant. So if we derive the formula will be where this is the concentration of A remaining in the aqueous solution after extracting aqueous volume with a unit of milliliter of the solution with an original concentration of this, with I portions of the organic solvent, each with a volume of organic volume. So let's have an example. The distribution constant for iodine between an organic solvent and H2O is 85. Find the concentration of iodine remaining in the aqueous layer after extraction of 50 milliliter of 1.00 times 10 to the negative 3 m iodine with the following quantities of the organic solvent. First is 50.0 milliliter. Second is the 2 per 25.0 milliliter portions. And lastly is 5 per 10.0 milliliter portion. So let's answer the first, which is the 50.0 milliliter. So let's write first the iodine. There you go. And then so in the formula, we're going to write here the volume of aqueous, which is the 50.0 ml. Then we're going to write here first the organic volume, which is 50.0 ml, 50.0 ml. And then we're going to multiply it by the distribution constant, which is 85. And then add it by the aqueous volume, which is 50.0 milliliter. Oops. So since hindi kasha, and then we're going to multiply it and we're going to write a superscript here, which is 1, and then we're going to multiply this whole by 1.00 times 10 to the negative 3. Then you're going to calculate it using calculator, and we're going to have an answer of 1.16 times 10 to the negative 5m. So this is the answer for the letter A question. So next, so for the second one, which is the given is 2 per 25.0 ml. So we're going to write again first the iodine. And then we're going to have a subscript of 2 because as the question said, it has 2 per 25.0 milliliters. So we will be having a subscript 2. So equals. So again, we're going to write here the aqueous volume, which is 50.0 ml, and then the organic volume, which is 25.0 ml, and then multiply it to the distribution constant, which is 85, and then add it by the aqueous volume, which is 50.0 ml. So, yeah. And then we're going to multiply it by 1.00 times 10 to the negative 3. And we're going, and the answer will be 5.28 times 10 to the negative 7 mole. So this is our answer for the letter B. Lastly, our given number is 5 per 10.0 milliliter portion. So we're going to write first again the iodine. And a subscript of 5, and then the aqueous volume, which is 50.0, and the organic volume, which is 10.0 milliliter, and then multiply it by the distribution constant, which is 85, and then add it by the aqueous volume, which is 50.0 milliliter. Then again, we're going to multiply it by 1.00 times 10 to the negative 3. And oh, I forgot, we're going to have a subscript of, a superscript of 5 because of this. So we will be having a superscript of 5. So, the answer will be 5.29 times 10 to the negative 10. So this is the answer for the last question, which is the letter C. So note that the increased extraction efficiencies that result from dividing the original 50 milliliter of solvent into two 25 milliliter or 5 10 milliliter portions. So that will be all. Thank you for watching.